Welcome to Homework Lib.
Hi, so over here what we need to do is perform the calculation of the theoretical and the yield percent for the reaction. So in this case we have an aldol reaction where we have a correspondence of 1 to 1 of the 3,4-dimethoxybenzaldehyde in the 1 own and the product. So I'm going to label this as radiant 1 plus radiant 2 generates the product. Just to keep track of the coefficients, we really don't need to write down the whole formulas. So, employing the information of the table that we filled on a previous question, we're going to detect which one is the limiting reagent. So, since this is a one-to-one reaction, the limiting reagent is going to be the one that is in least quantity. In this case, this corresponds to 3,4-dimethoxybenzaldehyde. Of course, this needs to be in quantities in terms of amount of mole. Recall that the amount of mole was calculated as the mass divided by the molecular weight. So we're going to have 1.476 times 10 to the minus 3 mole of product as theoretical yield. This, in terms of grams, can be found using again the molecular weight. So we have moles of product of the 2,3,4-dimethoxybenzalidine in that one own product. We know that the mass is of 280 grams per mole, so we need to multiply by the molecular mass. So by 280 grams per mole, and this would be equal to 30.78%. So this would be your theoretical yield, and actually in your experiment, your result should be a little bit lower because, as you can see from the temperatures of the recrystallized product, the range of temperatures in which your sample was melting is quite large, right? We have a 6-degree separation. So that is an indication that the product is not pure. Whenever we have a pure product, the range of the melting point is going to be small, as you can see from the theoretical result reported in the literature. So with that, it would be all. Thank you very much. And this would be your yield percent and the theoretical yield in grams and in moles of your desired product. Thank you very much and have a good one.